Hello friends, today's question. In the figure, the static friction coefficient between all the contact surfaces is 1 by 2. What minimum force applied leftward on the block 1 will move the system? Repeat the problem if the force is now applied on the block 2. So these are two blocks, block 1 and block 2. Block 1 is the weight of 1 kg and 2 is having the weight of 2 kg. And first of all, we are going to find out what is minimum force when the force is being applied on block number 1, and then we are going to repeat the same thing, but that is when the force is being applied on the block number 2. So let us divide this into first. Okay, let us consider the case 1. Force is being applied on block 1. Force is applied on block 1. So this is our block 2, and we have block 1. Okay, the force, let us suppose F is being applied on block 1, and if mu is the coefficient of friction for all the contact surfaces, okay, so this block 1 will try to move block 2 towards the left with the force Fr, and there will be equal and opposite force that will be acting. Let us call this Fr1 and this will be Fr1. Okay, and because of this surface here, an equal force or force will be acting Fr2 in the opposite direction. Next, we can draw the various tensions. Let us suppose this is tension T, this will be also T, and this will be also T. So accordingly, this will be our 2T. You can see there will be a force acting in the opposite direction because of tension, that will be 2T, and on the block 1 there will be a force of T, that is tension. So, and yeah, I think that's all. Now we are left with only finding the various normals. Okay, so we can see that Fr2, the total weight will be 3 kg. Let me write it here. The force is applied on the block 1 is F. Okay. So from the free body diagram of block 2, you can see that from free body diagram of block 2, you can clearly see that twice tension 2T will be equal to F R1. Okay, and we can find out value of Fr1. That value Fr1, there will be a 20 Newton in the downward direction, and suppose there will be a normal upward that is given as N1, and whose value will be given as 20. So we can say our Fr1 will be equal to mu into N1. Value of mu is 1 by 2 and N1 is 20. So we get Fr1 as 10 Newton. So you put the value FR1 as 10 Newton. So this will be equal to 10 Newton, or from here we can say tension will be coming as 5 Newtons. Okay. Similarly, we can find out FR2. Okay. So here the total weight will be 2 plus 1, that is 3. So this will be our 30 Newton. And let us suppose there is a normal of N2, the upward direction, whose value will be 30. So we can say that FR2 will be equal to mu into N2, which is 1 by 2 into 30, to 30, which will be coming as 15 Newton. And let us now free body diagram for block 1 from free body diagram of block 1. You can see that F is equal to, we have FR1 and FR2, FR1 plus FR2 and plus tension T. We know value of FR1, FR2, that is 10 and 15. Okay. So we can put the values here. We get 10 plus 15 and plus 5 Newton. So force, that is F, will be coming equal to as 30 Newton. Okay. Now we have case number 2. The force is being applied on block number 2. So we can say case 2. Force is being applied on block 2. And let us call this as F again, doesn't matter, whatever value variable we can take. Now let us draw the block number 2, block number 1, and we have a force F is being applied on block number 2. This block 2 will try to force move block number 1 towards left. Let us suppose it is given as FR2. So there will be equal and opposite FR2 here also. And because of the moment of, you can say, I think, there will be tension T this direction, and we are going to have a 2T tension here also. Okay, and I think now there will be 20, and there will be a normal N1 whose value will be 20. Okay, and for now, with the help of this tension, it will try to move towards right. So there will be a friction of FR1 in this direction. Okay. So for the free body diagram for block 1, from FPD of block 1, we can say tension T is equal to FR1 plus FR2, and we already know the value of FR1 and FR2, that is 10 plus 15, so we have tension T will be coming equal to as 25 Newton. Now for block number 2, from FPD of block 2, we can say that F will be equal to 2T plus FR2, and we know value of T is 25, so this will be 50, and we have FR2 as, one second, sorry, here it will be FR1, okay, otherwise, and this will be FR2, so that the variable remains same. So we have FR1 as 10, okay, so this will 10, so we get F in this case will be as 16 Newton. So this question was quite simple. The only thing we have to remember or try to find out that what will be the mutual relative forces which will be acting among the blocks. Once we are able to find out, then it is quite easy to use the algebraic sum of the forces and find the solution. Thank you.